So the focus of this article is about control and how it can help molders and mold makers have more control over a given mold. For molders, the control that they'll find is in the valve gate timing sequence and in controlling pressures and clamp force. For mold makers, it's going to help them figure out where gate locations need to be. How do we place them in the right spot so that we can time the valve gates appropriately to give us what we want in terms of knit lines or clamp force and so forth. Right, yeah, so if the question is, can I give you the absolute best gating locations? I think the answer is yes. I think I can probably give you 20 different ways to gate a given part, but is there a best way? Yes, absolutely. And the best gate location really depends on the requirements of that mold. Is it knit lines? Is it clamp force? Is it fiber orientation? Any number of things. But can we give you a set of gate locations that fits the needs to the best of our ability from all of those angles? I think the answer is yes. In the article, I mentioned 3 different ways to valve gate sequence, and these are just kind of general ways to do it, but and sometimes we combine ways within a given mold. But the 3 basic ways to do it are center out, cascaded, and for multi-cavity. For center out, you're looking at a part, and oftentimes they're long and narrow parts, and you'll start with a gate in the center, and depending on the length of the part, you may have 3 gates, you may have 5 gates, you may have more. But you start with that center drop and then let the flow expand outward, and when it reaches that second tier of gates, you fire those and on until the end. So the key there is that you start and you continue to build from that until you've got balanced flow. For cascaded, it's basically the same thing, except you're starting from one end of the part and flowing to the other. And there are some advantages of that, particularly when it comes to valve or fiber orientation. Fiber orientation, fibers all being aligned in one direction can provide some benefits for warpage or for the strength of the material, for example. And then the last one is the multi-cavity. So sometimes you have very large parts along with very small parts being molded in the same mold. And traditional molding without valve gate sequencing, you may have to bore balance the manifold to get the flow and packing to balance out. Well, the problem is you may have a very large bore over here and a very small bore over here, and if the molder gets his hands on it, so to speak, and changes the process, these types of molds are very sensitive to those changes. So any changes to the process in that situation may throw the balance off. So valve gate sequencing comes in, and you can turn valve gates on and off as you please during filling or during packing, so that you can not only balance the flow but balance out the packing. One of the main benefits of valve gate sequencing is reducing pressures and tonnages. So if you have a situation where you, for example, don't want any knit lines on your part or limited knit lines, you may go with a single drop. Well, for you to fill that mold, it may take a certain amount of pressure, and I pointed that out in one of the graphs in the article, but it may require a large amount of pressure. Well, if you add the number of gates, you're able to reduce not only the pressure but the clamp force that way.